one of the things we also need to look at are coordinate systems. How do we identify someplace in space? We typically use two coordinate systems. We use something that's called the Cartesian coordinate system and something that's called the polar coordinate system. The Cartesian coordinate system is going to give us our x and our y, and we can also do this in 3 dimensions, and then we get our z dimension, where everything is orthogonal, meaning they're all at right angles to each other, and I'm going to get my coordinate system. If I were to write this point as my x and y, that's how I usually represent my point, is x and y. And if I were to write down what this point is, this is going to be 0.32 in space. So I can locate that particular point in space by its Cartesian coordinate system. Well, one of the things that I also can do is I'm going to be able to convert this to a polar coordinate system. And in my polar coordinate system, I'm going to use something called r. That's going to be my radius to that spot. And then I'm going to use the angle. So there's my angle to that spot. So instead of an x and y, I'm going to use an r and a theta to represent my position in polar space. And the reason I'm going to do that is because eventually we're going to work in circles rather than in our regional or orthogonal system. And depending upon what my problem that I'm working on is going to depend upon which way I'm going to want to work in the system and how I want to have that system manifest itself. But I can convert back and forth. I can go back and forth between that coordinate system out there. So if I do this and I've got my r, so this is my r and this is my theta, and we said that in my xy system that this was 3 and 2. If I were to draw my points, there's my x, this is 3, and there's my 2 for my y. I can find out what r is because r squared is equal to x squared plus y squared. And now I can do that this is 2 squared, that's 3 squared plus 2 squared gives me 9 plus 4 gives me 13. So r is going to be the square root of 13. And that gives me 3.6. So I get that 3.6. I can figure out the angle because I said that the tangent of the angle is equal to the opposite, which in this case is 2, over the adjacent, which is 3. Do the arc tangent, use that little tangent to the -1 thing on my calculator. And when I do that, I'm going to get an angle of 33.7 degrees. So if I'm writing this in the r theta coordinate system, this is going to be 3.6 and 33.7 degrees. So I can convert back and forth. Everybody see how to do that? So I can convert back and forth to my polar coordinates. And the question now is, why on earth do I care? Well, I care because we describe things in position. We describe things in terms of vectors. And when we start motion here pretty quick,